Hello, everyone. Welcome to the Connect series. Today, it's just me, Adrian Fernandez. Nick, unfortunately, isn't going to be able to make it, but too bad for him because we got a very, very special guest here to talk about a very unique technology that we have, a software offering to make developers take full advantage of the different connectivity protocols we have in our portfolio and actually mix and match them in unique combinations. So to talk about this unique software solution, we're bringing in Marie Hearns. She's our sub-1 gigahertz software applications manager based out of our Oslo office. So Marie, thanks so much for joining us today and nice to see you. How are you doing today?
Hey, Adrian, good to see you too. I'm good, excited about this topic.
Awesome. Hey, me too. I'm here to be a sponge. I'm sure our audience is just as curious. So the topic at hand today is DMM, or Dynamic Multi-Protocol Manager. Could you tell us a little bit about what this technology is and how does it work with TI's connectivity stacks?
Sure, so the Dynamic Multi-Protocol Manager is a software module that you can use alongside with the protocol stacks from the SimpleLink SDK, which allows you to run BLE concurrently with a different protocol stack. So it means that you have one device with one radio, but you are able to run on two different RF stacks.
Awesome. That's really cool. And what are the implications of two protocol stacks sharing the same hardware? Is there any compromise in terms of switching time there? Having to switch from, let's say, Zigbee to Bluetooth or other combinations?
Yeah, I understand your concern, and there are two protocol stacks sharing one radio, but for our CC13XX and 26XX devices, we have best-in-class radio switching, so typically you can switch in less than 1 millisecond. We also do a good amount of testing for the DMM, and we always check the packet loss when running two radios at the same time. Sorry, two protocols at the same time. And we recently published an application note on this very topic. So if you are wondering about the performance for the DMM, you could check it out.
Awesome. And maybe just to reiterate one thing, what you mentioned is instead of having two radios trying to brute force their way, do things simultaneously, that could result in a lot of RF interference. But we inherently sidestep that issue by having one radio and they're just sort of symbiotically taking turns. And in that way, they're not competing with each other, but actually collaborating to enable that combination of use cases. That's awesome.
Yes, exactly. Yeah. And we also have spent a good amount of time on the DMM policy manager to make sure that it can work around different situations that may arise. And in most cases, you will be able to schedule a packet at a later time if there is a conflict. We very rarely see that a packet is being aborted by the policy manager.
Gotcha. Okay. And could you talk about the implementation here? Because does this mean I need two radios to run these two stacks in a single application?
No, that's the point of the software, that the DMM consists of two modules. One is a policy manager, which keeps track of what the stacks are doing and which priority should be given to which action. And then there's a scheduler component that takes all of the RF packets and makes sure that they're scheduled in the correct order and with the correct priority.
Oh, awesome. So we're doing some sort of time synchronization here where they're kind of sharing the hardware resource, and it's kind of an intelligent software module where I don't necessarily have to worry about it. DMM will take care of that for me.
Yeah, sure. And we also have a set of example applications in the SimpleLink SDK. So if you are running a Bluetooth Low Energy example alongside, for example, a sub-1 gigahertz proprietary stack or even a Zigbee stack, you can find an example application in the SimpleLink SDK that will allow you to run more or less without doing any configuration.
That's fantastic. So you touched on some of the combinations that are possible. Could you maybe explain the use cases? Why would I want to do this as a solution provider?
That's a good question. So we see that in some cases it's not enough to have one RF protocol with our new situation where Internet of Things is virtually everywhere. So one example that we see is that your product needs some kind of Bluetooth Low Energy configuration layer, and you want your user to be able to interact with your product through, for example, a smartphone. But you also wanted to have some other connectivity. For example, as I mentioned, a sub 1 gigahertz network, Zigbee, or any other connectivity that you already had on your product. So by adding DMM, sorry, go on.
No, very cool. I was just I guess reiterating how cool that is. That's great.
And a different use case that we also saw customers taking advantage of is that if you have network that is running over a relatively slow RF protocol, for example, a mesh network, you can use the DMM to run specific data-intense operations, such as an over-the-air firmware update, and you run that operation over BLE, which has a higher data throughput. And this will allow you to do a quicker over-the-air firmware upgrade, but it will also save you power since you are sending the packets at a higher data rate.
Wow, okay, that's really cool. So, you could take advantage of protocols like Zigbee, Thread, a proprietary protocol, whether that be a star topology or a mesh protocol, but then essentially have Bluetooth as a companion sort of protocol that's sort of available to developers for unique use cases like provisioning, over-the-air download, or maybe even as a remote display. Most of us have a cell phone or a tablet available to us, and this allows them to get some sort of almost human-machine interface to an edge node, for example, by having that Bluetooth connection available. That's really, really cool. And what are some of the practical examples here? We talk about Bluetooth being available in a Zigbee protocol or a proprietary protocol. Could you talk about some of the applications here? Are these building automation, factory automation? Where are we seeing this being used?
Yeah, we have, for example, inside building automations, we have customers that use the TI 15.4 stack, which is a star network that you can run over sub 1 or over 2.4 gigahertz. And in this case, let's say it's a TI 15.4 stack running over sub 1, so it has relatively long range and the nodes can be spaced far apart. And if an operator comes in and needs to read out some information or do some configuration, it's very practical to add BLE to this product, because in that case the operator can directly interact with each device using BLE, and he doesn't need a dedicated operator device to interface with the sub 1 TI 15.4 stack.
Yeah, that's awesome. Yeah, so you kind of get the best of both worlds, the sort of accessibility, ease of use of Bluetooth, but then pair that with the long range, low power of sub 1 gigahertz, for example. So really, really cool to see that flexibility being enabled by DMM. So really cool, Maria. I learned a lot. I'm sure developers here are super excited to jump in, maybe evaluate this for their specific use cases. Where can they go to learn more about DMM and how to get started?
To get started with DMM, I would recommend going to SimpleLink Academy and start with the DMM Fundamentals training, where we explain how to set it up and what kind of hardware you will need to start checking it out.
Awesome. Well, I'll definitely check it out. We've got the URL here. I think it's ti.com/learndmm. So really excited to have you here, Marie, to enlighten us about DMM. And thank you, viewers, here for watching. Hopefully this is a technology that you'll find useful in your applications. It's not just one protocol, but potentially two working in unison with the help of this really cool software product coming from Marie's team. So thank you, everyone, for watching, and we'll catch you guys in the next one.